This optimization problem is about finding the minimum perimeter of a three-sided rectangle. Suppose we want to build a rectangular pasture to raise animals. One of the sides is adjacent to a river, so using fence is not necessary. The area of the pasture must be 180,000 square meters. Find the optimal dimension that minimizes the amount of fencing. So what is minimize the amount of fencing? So let's say you go to a store and then you're trying to buy some fence. So and then you pay and then you will get this, right? So you will get some fence. So let's say you put them like a line, and then what we are trying to do is we are trying to build a pasture. So do you see this? Do you see that there is a length and then there is a width? So since one of the sides is adjacent to a river, so we don't need to build any fence for that size. This is an optimization problem. The first step to solve an optimization problem is you have to draw a picture, nice and big, and you have to label your picture. So what we are trying to do is I buy some fence and then I need to make a cut. So let's say I make a cut right here. So let's say I make a cut right here and then make a cut right there. So after you do the cut, then we have this is my length, and then we have a width, and then we have a width, right? So what I'm trying to do is tell me the length and width that minimize the amount of fencing. So what is X and what is Y that minimize the fencing? And also when you find the area, X times Y must be equals to 180,000 square meters. So what X equals to what, Y equals to what, such that the perimeter is minimized and the area is equals to 180,000. All right. So let's erase this. So now we got a picture. Oh, by the way, the picture, when you solve an optimization problem, it is your responsibility to draw a picture. 95% of the time, the problem won't provide a picture to you. You have to draw your own picture. That is your job. And then step 1 is draw a picture. And then what is step 2? Step 2 is step 2 and step 3. You have to do these two steps simultaneously. Step 2 is you have to figure out a primary equation. So step 2 is primary. I will just call this a function. So what is primary? Primary is, what are you trying to answer? What's the question? The question is minimize the amount of fencing, right? So minimize the amount of fencing means you are trying to minimize the perimeter, because if you buy too much fencing too long, then you are wasting money. So what is the perimeter of this rectangle? So the perimeter is equals to X plus Y, right? So that will be X plus 2y. So I cannot call this a function yet because we have two variables, X and Y. And then in order to write this primary function in terms of one independent variable, we will need a secondary equation. So that brings me to step 3. Step 3, let me use a different color to write step 3. So step 3 is secondary function. What is secondary? Secondary is what is given. The given condition is area equals to 180 square meters, right? So area is equals to X times Y. And then what is the area? The area is 180,000, right? So that is equals to X times Y. And then can you put this Y equals to some X? Of course. So this is Y equals to 180,000 divided by X. And this is my secondary equation. And then the next step is you have to plug in the secondary to the primary. So I am going to plug this in to where? I am going to plug this in to my primary. So now after the plugin is done, the primary is in terms of one independent variable, and then you can start taking derivatives. So now I am not writing P anymore. I am writing P of X. So that is equals to X plus 2 times 180,000 divided by X. So now the perimeter function is in terms of one variable. And then you have P of X. So that is equals to X plus 2 times 18 is equals to 36, right? So we have 36, 360,000, and then times X to the negative 1. So that is my primary. And then how do you find the absolute minimum and absolute maximum? you take the first derivative, right? So we take the first derivative. So we are going to do p prime of x. So what is that equal to? Simple, right? The derivative of x is equals to 1. And then you bring the negative 1 down. So you have negative 1 minus 1 that equals to negative 2. So you have minus 360,000 x to the negative 2, right? Negative 1 minus 1 is negative 2. And then p prime of x. So that is equals to 1 divided by 360,000 divided by x squared. And then how do you find the minimum and maximum? You have to find the, what is that called? That is called the critical number. So to find the critical number, you have to set that equals to 0. And then you have to solve for x, right? And then why do we have to set that equals to 0? Because let's say we have a parabola. The reason I set that equals to 0 is because at this critical number, the tangent line is horizontal. That means the slope is equals to 0. And then if you can prove decreasing and then increasing, then at that critical number, we call that a minimum. So that's why we have to set that equals to 0, because at that critical number, we have a horizontal tangent line. So that is erase that. And then how do you solve for this? So first of all, I will put the negative to the other side. So I have 1 equals to 360,000 divided by x squared. And then multiply both sides by x squared. You have x squared equals to 360,000. And then you take the square root on both sides. Do you still need to use the plus or minus? No, right? Because length cannot be negative. So x is equals to the square root, no more parts, plus or minus. 360,000. So x is equals to 600 and the unit is in meters. Okay, so this is what x equals to. So at this point, we know that when x is equals to this, the perimeter is minimized. But you have to give me some more proof. So this one is x is a solution, right? So we can also call this critical number. Can you prove that at x equals to this, the perimeter is minimized? So this one, I will be using the second derivative test. What we just did is the primary, so step 3, and then this is called step 4. So step 4 is derivative, and then critical number. And then step 5, you have to prove the min and max. So step 5, allow me to change to a different color. So I am going to move over here. So we are doing step 5. Find the min or max. Let's use second derivative test. So second derivative test, so what is p double prime? P double prime, the derivative of 1 is equals to, where is the first prime? The first prime is right over here, right? So the derivative of 1 is equals to 0, and then you bring the negative 2 down, take the negative 2 minus 1, right? Okay, so that is equals to 0. So once you bring the negative 2 down, so you have a positive. So 36 times 2, that is 72. So you have plus 72. 720,000 divided by negative 2 minus 1 is negative 3. So you put the negative 3 in the denominator and you can change the power to a 3. Do we need to set that equals to 0? No, we are not setting that equals to 0. This is called second derivative test. Okay, and then what do? We are not setting that equals to 0. Then you have to test the minimum value, which is x equals to 600. So what happened when x is equals to 600? Then you have 720,000 divided by 600 raised to the third power. I don't really care what that equals to. All I need to know is that is positive. So second derivative positive. What does that mean? Second derivative positive, that means the perimeter function is concave, what? Concave up when x is equals to 600, right? So concave up. So P is concave up when x is equals to 600. So draw a picture. So this is concave up, and then at this point we have a horizontal tangent line, right? And then this is x equals to 600. Then is this a minimum or maximum? Then x is equals to 600. This is a absolute minimum, right? And what is this test called? This is called the second derivative test. So when x is equals to 600, we have an absolute minimum. And then can you find the y for me? Because we are not done, right? I need the dimension, so I need the y as well. So the y is, so you have to recall the area function. So the area function is a equals to x times y. So right over here, so let's change to a different color. So we have an area equals to x times y, right? And then this is 180,000 equals to x is 600, and then equals to y. So you take that divided by 600, then y is equals to 300 meters. So 300 meters. Okay, so now the job is done. So now it's a time to write a conclusion and then submit the conclusion to your boss. And then you have to do this, and then you draw a picture. This is river. And then you draw the pasture. So here is your pasture. And then y is equals to 300, right? So this is a 300. And then what is x equals to? X is equals to 600 meters, right? So this is your pasture. And then what is the area? How long? What is the not the area? What about the perimeter? How many meters of fence do I need to buy? You have to tell your boss, right? So the perimeter is equals to 300 plus 300 and then plus 600. So you have to tell your boss that you have to purchase 1,200 meters of fence to do this job. Right, so you have to draw a conclusion and then submit to your boss. So you provide a picture. This is exactly what we want, and this is the length of fence that you have to buy. All right, so that is the end of this video. If you think my instruction is helpful, if you like it, you think this is helpful, give me a like, share, and subscribe, and I will see you all next time.